So recently I've been working on a little game engine in C for fun, and I've hit the point where I need to render some text. Now normally text rendering is really annoying and difficult to do, but there is one method that is pretty easy to implement. That method is called bitmap font rendering. And if you don't know what it is, bitmap font rendering is an old technique where you have an image with all of your characters pre-rendered onto it, and then you just sample different portions of the image and assemble those into a string of characters and draw that onto your screen. It's simple and it's old, so it has some limitations, but it is a really nice and easy way to get font rendering into an engine or a game. So today we're going to be building this together. It's not exactly going to be a tutorial, but I am going to be thinking out loud and explaining all the key concepts that you need to know. And on that note, I'm going to be using the Sokol library for windowing and graphics, and I'm going to be using Sokol GP, which is a single header file that provides 2D rendering to Sokol. Of course, the technology that you use does not really matter. It's more about the key concepts here, but just in case you wanted to follow along exactly, that is what I'm going to be using. And on that note, all of the code that's in this video is going to be linked in the description in a GitHub repository, so go ahead and check it out there if you just want the source code. With that being said, let's go ahead and actually implement this. So I have just a little initial starter project here because I didn't want to write a ton of CMake on camera, but it's basically just the minimum amount of code to open up a window and, clear the background with a nice color here. But yeah, let's go ahead and actually implement this thing. So I have two files here. I have bitmapfont.h and bitmapfont.c, and that's all we're going to need to actually implement this here. So the first thing I'm going to do is I'm going to just make like bitmap font h like this, just my little header guards here. And then I'm going to define bitmap font h and do a little endif here. So now that we have our include guards in here, let's actually think about what we need to implement this font thing here. So we're going to need some sort of object that holds all of the different parameters of our font. So like how wide are the characters, how tall are the characters, what's the padding between them on the source image, things like that. So for that, I'm going to create a struct that has all these different settings. So I'm going to create a typedef struct, and I'm going to call this the bitmap descriptor here. So bitmap desk. And I'm just going to put it down here as well. And let's actually think about what we're going to need to provide in this description. So the first thing we're going to need to provide is the actual source image here, which for me is going to be a Sokol graphics image, so SG image here, which of course, if we're going to use that, we need to then include Sokol graphics as well. And then we're going to need a couple different bits of information about this image. I guess we're going to need the width and height in pixels of this image here. So I'm going to do uint32t image width in pixels like this. So width in pixels. And we're also going to need the height in pixels as well. So let's just make this the height in pixels. Then we're also going to need some settings about each individual character so we know how to crop it. So we're going to have the character width in pixels and the character height in pixels. So character height in pixels here. We're also going to need a couple other things. So there is a small gap in this image here, which I guess I should pull it up. If we go to this image, and open it up here, you can see that this image is very small, but there is a single pixel gap between each of these characters, and we need to account for that whenever we load things in. So let's go ahead and put that in here. So I'll just do uint32t char padding pixels like this. So this should be padding x, and then we should have padding y like this. And then we need a couple other things. So we need the const char chars, and we need size t num chars, which I'll kind of explain this more in detail in a bit, but this is basically just going to be the list of characters in order that are listed on the atlas, and this is going to be the number of those characters that are in this source image here. By the way, sometimes I'm going to be saying atlas. Atlas means image. It's a texture atlas, so I do slip up and I say different things, but texture atlas, image, I'm saying this, I'm referencing this here, so that's what I mean. So now the next thing on our list, we're still writing a bit of boilerplate here, but we need to actually define the bitmap font. So typedef struct bitmap font like this. This is the actual thing. This is the thing that gets things done here. So typedef struct bitmap font, and inside of here we want to store those settings. So we'll say bitmap desk, and I'll call this my options here. Now there's a couple other things that I probably want to put in here, but for now I'm just going to put size t pointer here, and this is going to be our character jump table, which I'm going to explain in a little bit when I actually implement it, but this will essentially map ASCII values to indexes into our texture image here. So that's what that is for, which I will explain more when I actually implement it here. So there you go. That's kind of what it's going to look like. That's the data that we need here. So now let's go ahead and define the shell of some different functions. So I guess the first two functions we should write are the init and the free functions here. So I'm going to do a bool bitmap font init here. Now bitmap font init is going to take in the bitmap font self like this, and the boolean is going to be true for success, false for failure. Then I'm also going to make a void bitmap font free and pass in the bitmap font self like this, which will essentially just free the bitmap font here. So we're also going to need the actual bitmap descriptor here. So bitmap desc, and this will be our options like this. And that is essentially all that we'll need for this initial implementation here. Let's go to bitmapfont.c and let's actually include that bitmapfont.h here. And I'm also going to split the pane so that I can reference this here as well. So we're going to now actually implement these two functions here. So let's go ahead and just copy those over here. Now the first step to actually, be a good programmer, I'm going to make sure that the bitmap font is not null. So we'll say if not self, then just return false. So that's just my, good programmer practice right there. So we go ahead and do that. And then we're going to need to do a couple different things. Now that we have that out of the way, all we need to do is just do self arrow ops equals the ops. And we have done most of what we need, but we do need this character jump table. Now, this character jump table is a little bit interesting. So what do I mean by a character jump table? Well, what we're basically going to do is we're going to take a character array that the user passes in, or the actual programmer of the game passes in, and we're going to loop over the characters in that array, and we're going to grab out the ASCII value of each of these characters. We're then going to map this particular ASCII value to an actual location on our bitmap font. So we would, for example, let's go to this image here. We would map this G key here. We would map the G ASCII value to whatever this index is here. So this would be 0, and then we would continue on, 1, 2, 3, 4, 5, etc., up until the value of G. We'd be mapping the ASCII value to this index value in the image here. So once we do that, then we can just very, very quickly just do these quick mappings whenever we're actually rendering things, which makes this a really, really fast way to render text. Okay, so let's go ahead and actually make some functions for doing this. So I'm just going to make a couple different functions here. The first one is going to be a very simple one. It's just going to be a find max function. So it's just going to do a find max. And this is just going to essentially loop over the const chars, and we're going to have a size t num chars like this. And we will just first say if numchars equals 0, then return 0 to make sure that, we don't look outside of the bounds of the array, because if it's 0, we can't loop over anything. And then we'll say size t max value equals chars at 0. And then we'll say for size t I equals 0, I is less than numchars I plus plus. If chars at I is greater than max value, then max value equals chars at I. And finally, we will just return the max value. Now, why do we need this maxima function? So my approach to this, which is a very, very simple approach, but all you do is you just create a buffer of pointers that is a sparse buffer from 0 to the maximum ASCII value. And with that buffer, you can then just directly index into it by your ASCII value. And at the ASCII value index, it will have the index into your image here. So now the next thing to do is to actually build a function that builds the character jump table. So I'll just say boolean build character jump table. This will take in, it'll take in the actual allocated table. It'll take in the const char chars, and then it will take in the size t number of characters here. So first things first, if not table or not characters, then just return false, because they need to be valid for this to work. So we are assuming that the table is allocated and allocated to the correct size. So that's what we're assuming. It's a big assumption, but this is only defined in our C file. It's not meant to be called by anything. So we can make that assumption also because I'm a one-person team. So there you go. Anyways, now what we can do is we can just kind of loop over this and just create this jump table. So we'll just say for size ti equals 0, I is less than the number of characters, I plus plus. And then we can just say table at the characters at I equals I. Now we can typecast this into a size t to make it behave. As you can see, what we're doing here is we're literally just typecasting the character into an index. We're mapping that to the actual index value of this character in the bunch of characters that we're going to be. And by the way, if you don't really know what I'm talking about here, this characters thing is going to look like this. It's going to be like A, B, C, D, E, F, G, H, I, J, J, K, like this. The user is going to pass in something that looks like this. And then from there, it would then map it. So that's what's going to be happening here. Okay, so now let's go ahead and actually do that here. So we'll say size t max value equals find max value, ops.characters, and then ops.num characters here. Okay, and then we will actually create this buffer here. So size t table equals, and then we will do, let's see, malloc. And for malloc here, we're going to do max value times the size of a size t. Which we're going to need to include the standard libs. And we'll say if not table, then we have failed here, so we can return false. Then we can just call the build character jump table, pass in this table here, pass in the ops.characters, and pass in the ops.num characters like this. And we can also say if not build characters table, then we can return false like this. So there's our constructor. Finally, all of that is done. And then for the free, we can just go in here. We can say if self and self arrow character jump table, then simply free self arrow character jump table and self arrow character jump table equals null. So we're not pointing into a random spot in memory. So that's actually done. And now let's go ahead and go back to our header file here. And let's see if we can add an actual useful function in here. So I think the first thing we should do is get a function that can draw a singular character. So to do that, I'm just going to create a function here called bitmap draw char. This will take in the bitmap font that we have created here, the actual character, and then it will take in the destination rectangle, which I'm going to be using this Sokol GP rect here, which is provided by Sokol GP. As long as you have some sort of structure that has an X, Y width and height, or an X0, Y0, X1, Y1, 2 points. Either one works, but the math is a little different for the latter. But as long as you have that, then you're good. So pass that in there. Of course, I'm going to need to import Sokol GP at some point. So Sokol GP there. So that's our definition. Let's go ahead and actually do this. So I'm going to put it down here and let's see. So if we want to be good citizens, of course, if not self, then just return. Although I probably wouldn't put this on my own code anyways, because I just trust myself. The next thing I would do is I would actually grab the index. So we'd say size t index here equals self arrow character jump table at the size t typecast of the character C. Now this does have a slight security risk if you use a character that is greater than the max ASCII value here. The way around that is to simply store the max value in your bitmap font and then have a little check on this before that. I'm really lazy, so I'm not going to put that in this video, but you go for it, do what you want. So let's go ahead and actually do the math for this. Now to actually grab the location in pixels on the image of which you want to crop out, we're going to need to do a little bit of math. So this location here, we need to grab the X here and then the Y, which goes from 0 downwards traditionally with these sort of texture coordinates. We're going to grab this X and this Y here. I think it's a lot easier to separate this into a couple steps. The first one is we're going to grab the tile X and the tile Y. So the X and the Y in terms of tiles or number of characters. So I'm going to do that first. So uint32t x tiles equals, and this is going to be the index, and it's going to be modulus divided by the self arrow, and then it's going to be ops, and then it's going to be image within characters here. Do I have that? Ooh, I don't have that. This is why it's not quite an actual tutorial, because I haven't done this 100%, I haven't like 100% gone through this already. I have made a ton of bitmap font renders in the past, but I don't have it like in my head. So we're gonna need a couple of these, and I don't want the user to have to specify this because this is just something that can be solved with math. So we'll just make this, within characters here like this. So within characters like this and height in characters like this, which does kind of complicate our constructor slightly. So we can do self arrow image within characters here, and we can just divide this by our ops dot character within pixels, I think. Character within pixels, something like that. Oh yeah, it should be equal to ops dot image within pixels divided by ops character within pixels here, which should also be plus ops dot padding here. So yeah, char padding like this. I think that'll work out. And then same thing for here, but instead of width, it's height. So just substitute width for height like this, and then also change that to y pixels. So let's see if that works. Then inside of the draw character here, we can actually use this here. So we can do self arrow image width in characters like this. And then we can do the same thing for y. So y tiles, and this is going to be divided by. And then to actually turn this into the pixel value here, we can then do u in 32t x in pixels equals x in tiles multiplied by the self arrow ops dot character width in pixels plus the self arrow, and this is going to be ops dot this padding, right? Yeah, padding x in pixels like this. And then for the y, it's going to be the same idea here. This basically the same math, but with the y tiles here. So that's all of our math done there. Then we're going to do our API specific draw call here. So I'm going to do SGP draw, and I'm going to do texture direct here. So texture direct. So this is going to take in a channel, which we're going to provide. I'm going to actually make it so that we store that channel, but for now I'm just going to make it 0. And then for the destination rect here, we're just going to be using the one the user provides. And then for the source rect, we're going to create that here. So SGP rect like this, x equals x pixels, y equals y pixels, and then the width equals self arrow ops dot character width in pixels, and for the height it's going to be the character height in pixels. Okay, cool. So that's that. Let's actually go ahead and maybe see if we can get this to work. Okay, so we're now in the main file. Let's actually go ahead and see if we can implement this and get a character on the screen. So I'm going to include our bitmap font.h, and then inside of the global state that I have here, I'm just going to create a bitmap font and just call this my font like this. And then inside of the init part of my game, I'm going to say bitmap font init here. And then I'm just going to pass in that state dot font, and then for the bitmap description, we're going to need to do the description here like this, but I'm also going to wrap this in an if statement. So if not bitmap font init, then I will simply do printf failed to initialize bitmap font like this. And if that happens, then we should probably fail because that's not so good. So let's go ahead and actually fix that there. So there we go. We just crashed the program if that doesn't happen. So before we actually provide all these description things, we need some data. We need the actual characters that we want in order, and we also need the image data. So let's go ahead and actually do that kind of stuff here. So I'm just going to copy over some code, which is essentially just the list of characters that we want here. So it's just going to be this here, and I think I have to include string for this, which we can then pass in here. I can then put in the parameters here that the characters is just equal to these characters, and the number of characters is equal to the nchars here. Now, in order to load in images, I actually added a couple more files. I added these image files here that I use for just quickly loading in images, and I also added stb image in here too, just so I can quickly get something loaded in. So I'm just going to include image.h, which is my own file here, and then inside of here we're going to actually use this. So I will just load in my data. So and cool, now we can do image equals image, We can now also do image width in pixels equals image data dot width, and we can do that should be image width in pixels, and this should be image height in pixels, and this is image dot height. Cool. What else do we need? I forgot. The character padding X is equal to 1, and then the character padding Y is equal to 0 because there's only one row on mine. Oh, I need a couple other things. I need the character width in pixels, which is equal to 3, and the character height in pixels, which is equal to 5. That should be every single thing that we need. And yes, that is a bit of setup. You could just make a wrapper function around this and it would help a little bit with some of this boilerplate. But you know, to keep it simple so we don't have to do too much parsing, you just have to do a little bit extra setup like this. Also, Clang is formatting this really weirdly. I don't know why it's so indented, but anyways, there you go. That is how it is done. Now let's go ahead and go to cleanup and let's actually do bitmap font free and then pass in our state.font like this. And first things first, let's actually make sure this runs without segfaulting or anything like that. So let's see. Oh, and I also have to update my CMake thing here. Okay, and so we now have this here and it seems like it actually ran without issues and I can close it. And we have a segfault, which is not good. Okay, so I found the culprit. It should actually be an inclusive range, and I totally forgot about that. So add 1 to your max value whenever you're actually allocating the table here. Otherwise, it will, go 1 outside of the bounds and then segfault. So, just add that. Sorry, totally didn't catch that at first. But now we should see that it actually does not segfault. So there you go. We are getting a lot closer. So let's go ahead and actually use it here. And the way you do that for this platform specific code here is I can do sgp begin, and this is going to take in the width and the height. So we're going to also need to grab the int width equals sap width and height here, height like this. And then we can do sgp begin, pass in the width and the height. We also need to do sgp viewport. And this just makes everything easy because I like to work in an environment where the top left is 0, 0, and the bottom right is the screen width and the screen height in pixels. So I'm just going to pass these in here so it makes it easier for me to work with. You can, of course, use whatever viewport you want. It just makes the math different. Then we can just do sgp set image, which sets the current image to be used by sgp. And for the image, I'm going to use our font, so state.font.ops.image like this. Quite a lot of nesting in there. And then what we can do, our actual call, so bitmap draw character like this, and then we'll do date.font, and then for the character I will just put a, and then for the rect I'll put sgp rect like this, and then for the x I'll do 100.0 f, and for the y same, and then for the width same, and then for the height I will put something more. So I'll do this. I'll do 300 and 500 here, so it's at least proportional. And this also needs to be single quotes. Forgot about that. Whoopsies. And then we need to do sgp, and then I think it's what, end? sgp end, sgp commit? No, there's no commit. It's just sgp end, right? Oh, we do need to do sgp flush though, I do believe. Cool. This should be everything that we need to render a character on the screen. Let's go ahead and see what happens. Boom, we got a character on the screen here. So this is what it looks like. It looks pretty decent. Now we need to actually get rid of that background, which we can do that with just sgp set, and then I think it's blend mode here. And then we can do sgp blend multiply, or is it add? I think it's add. I can't remember. I think it's add. This will just not add anything with the all black background, so then it looks like this. Cool. I'm also gonna shrink this down a little bit because I want to be able to render more text, so that should be good to go there. Okay, so now we have a character on the screen. Let's actually make it a bunch of characters. So I'll make a new function, and I'm gonna call this my bitmap draw line. This is just going to take in a const char content, and then a size t num characters like this. Now let's go ahead and copy this over to bitmap font.c, and we will just put this here like so. So this can be as simple as just looping over the characters here. So for size t I equals 0, I is less than number of characters I plus plus, and then we can just do bitmap draw character, pass in self here, and then for the character we can just do content at I, and then for the rect we will just do rect here like this. And then for the rect here, we will just do sgp rect, and then we will do x equals r dot x plus, and then it's going to be I times self arrow, and then it's going to be self arrow ops dot character width in pixels like this. And then for the y, it's just going to be r dot y for the y, and then for the width, it's just going to be the width, so r dot width, and for the height, it's just going to be the height that was passed in. So this will just draw it with the width and height provided and the initial x and y, and then just go to the right from there on out. So there you go with that one. So now let's go ahead and actually use this. So let's go to our main.c, and instead of doing draw char, we will do draw line, which we can then put as hello world like this to get our little hello world statement here. And I think, what else are we gonna need here? Oh, we need the number of characters here. So let's actually put it up here, and let's say const char content equals this. And then we'll say size t n chars equals stir len of our content like this. I'll put content n chars like this. And that should be good to go there. Let's go ahead and run this. And that is not what we want to see. Whoopsies. Oh, it shouldn't be self.ops.character width in pixels. It should actually be the display width. So it will be I times r.width like this. Now let's go ahead and test it. So we have hello world here, but as you can tell, the spacing is all messed up. So the reason is because there's actually no spacing at all. They're all just like right up against each other. So we can just make that a parameter here. So inside of bitmap font here, I'm going to add a float gap here. And then inside of bitmap draw line, we're going to add this float gap like this. So float gap there. And then here we're going to need to add that gap, which I'm just going to put as 10.0f like this. That's not correct. Wait, what happened there? Oh, I also have to actually apply that gap, which I totally forgot about. So it should be r.w, and then to wrap that in parentheses, plus the gap. So just plus gap like this, and that should add the gap into consideration with the math. And there you go. We now have a nice pretty gap here. Okay, so that's bitmap draw line, but what about drawing multiple lines? So why don't we do that here? We can do void bitmap draw lines plural, and I'm just going to take the contents in here and paste it in here, and then we're going to make this a gap x, and then we're also going to have a gap y like this. And now what we need to do is basically the exact same thing, but we also need to now keep track of the x and the y values here. So we'll say, let's say float x equals r.x here, and then float y equals r.y. And then for this, we're just going to directly use those values. So just swap these in for y, and then we will simply put x plus equals, and let's say r.x plus the gap of x. We'll do a check at the top here. So we'll say, we'll switch on the content. So we'll do switch content at I, and then we will do case. And then for this one, we'll do a new line character. So if it's a new line character, then what we want to do is we want to reset x to the start here, which is r.x. And then we want to increment y. So we'll do y plus equals the r.height here, which is what we should be incrementing by. And then we also, which actually tells me that this should be width here. So whoopsies there. Increment that by r.h plus gap y like this. And then also we need to essentially continue the loop, I think. Is that allowed in C-switch cases? Will this continue this for loop here? I don't know. And then for the case of \t, we can just pick what we want. So we can actually do, let's see here. We can do x plus equals r.w plus gap x times 2. And then we can just do a continue like this. You know, that's a 2-character space, or a 2-character space tab right there. And then just default will simply break out. Let's see if that works. I don't know if continues work in this context. We will see how that is actually handled. Let's go ahead and test it out. Let's actually add this into our bitmap font.h, like so. And then let's go to our main.c and let's make this lines, which is now going to take in a gap y here. So I'm just going to make it the same, I guess. And then for this, I'm going to put hello world, hello from YouTube, like this. I don't know if those are actually added in there, so I'm gonna do this. Let's see what happens. 3 lines. Wait, oh right, I didn't have caps. I didn't actually add caps. So let's actually make these caps. These should be caps here, or not caps. I didn't add lowercase. Make these lowercase. Now we should be good to go here. Let's see. All right, so there you go. There's first try for you. So hello world, hello from YouTube. Okay, now let's actually add a tab because I totally forgot to test that out. So we'll do \t here and let's see what that looks like. Boom, we got tabs. So I know what you're thinking, right? Int main return 0. So there you go. We have some text. Now, of course, this is really low res text because I drew it and I didn't want to make super high res text because I'm not a font designer. So there you go. We can now add text into our game, which is pretty nice stuff. So that's a pretty rudimentary implementation of a bitmap font renderer in C. So I hope you enjoyed this whole process here. Now in the description, what you'll probably see is that the code is going to be cleaned up a bit. So just for a couple things, I'm going to add comments explaining some things. I'm also going to be using some personal library tools that I have here. I like to use allocators as objects and things like that. And I also like to use string slices to wrap around. And I also like to use string slices instead of passing in const chars like this with the, number of characters like this. I don't really like doing that because it feels kind of janky and I don't like having to declare it above where I'm actually drawing the characters here. So I'm going to be fixing that in the example, but that also means that you do need to, have a couple extra header file dependencies here, which are just a couple different header only files from my other project here, which just has like a very, very simple allocator and a string, things like that. So, just a couple little extra things there, but that's just for my sake, because if I want to use this tool, I want to use the things that I like to use when I write C. So yeah, anyways, not really a tutorial, and I probably did derail a little bit there as I got a little bit into more territory that I don't have off the top of my head. So hopefully that was okay, and hopefully you made it through it. If you enjoyed this video, make sure to like and subscribe. And if you have any questions or comments or anything like that, make sure to leave them in the comment section below. I will try to respond to as many people as possible. If you like content like this, if you want to see me just like make some stuff in C, of course I love to write low-level C code, so please tell me that, so I will continue to make videos like this. The support of this video directly kind of correlates to whether or not I'll actually continue making these kind of videos, so keep that in mind. Also, if you're interested in this sort of content, if you like things like game development, graphics programming, Linux, things like that, then consider joining my Discord, where I and a bunch of other like-minded individuals love to talk about all this sort of stuff and share what we're working on, things like that. And then finally, consider supporting me on Patreon so I can continue making videos like this. Thank you very much for watching. Have a good day. See ya.